When Soviet tank crews first encountered the Panther on the Eastern Front in 1943, fear swept through their ranks. The Panther's sloped frontal armor, capable of deflecting even the formidable 76.2mm shells of the T-34, combined with its powerful 75mm KWK-42L/70 gun, gave it a deadly advantage at long ranges. Its debut at the Battle of Kursk, despite initial mechanical issues, marked a new chapter in tank warfare. Reports of Panthers knocking out Soviet T-34s from over 1,500 meters began to circulate among Soviet intelligence. These accounts intensified after field actions like those of Panther crews from the 2nd SS Panzer Division Das Reich, who during the 1944 Normandy campaign executed textbook long-range ambushes against British armor, including Shermans and Fireflies, near Caen. The Panther's sleek silhouette and fearsome capabilities turned it into a battlefield legend, less a tank, more a stalking predator evolved for one purpose: domination. Yet this German superweapon harbored fatal flaws that would ultimately doom it. Beneath its fearsome exterior lurked a web of catastrophic engineering compromises that transformed Germany's supposed war winner into a strategic liability. Let's dissect the Panther's fatal flaws. The Panther's transmission system represented one of its most critical weaknesses. Developed by engineers at ZF Friedrichshafen, the ZF AK-7-200 gearbox attempted to solve the fundamental challenge of transmitting 700 horsepower to 45 tons of steel. During field exercises at Kummersdorf Proving Grounds in February 1943, test drivers reported alarming failures. Final drives regularly broke down after just 150 kilometers of operation. The root cause was not material quality, but fundamental engineering. The planetary gears measured only 250 millimeters in diameter, nearly identical to those used in the much lighter Panzer IV, creating enormous stress concentrations during turning maneuvers. Oberst Hermann Balk, commanding a Panther battalion in the Großdeutschland division, logged these failures meticulously. His records show a significant number of early Panthers became non-operational due to transmission failures during Operation Citadel, never encountering enemy fire. The 80mm thick frontal glacis plate proved irrelevant when most tanks couldn't reach the battlefield. This engineering compromise stemmed directly from production constraints at Daimler-Benz and MAN facilities. When General Inspekteur der Panzertruppen Heinz Guderian inspected production lines in December 1942, he demanded an immediate deployment despite technical engineers' objections about inadequate testing. As a result, early models featured single-stage planetary gears to simplify production, saving time but catastrophically reducing durability. The Maybach HL230P30 engine itself represented another paradox of excellence undermined by practicality. Chief engineer Karl Maybach designed the 700-horsepower V12 with performance parameters exceeding contemporary Allied power plants, but its tolerances proved unsuitable for frontline maintenance. The engine required high-quality lubricants, increasingly unavailable after Allied bombing and material shortages. Maintenance records from the 11th Panzer Division show average engine life declining from 1,500 kilometers in mid-1943 to just 800 kilometers by early 1944. General Guderian wrote in his memoirs, "The Panther was a superb fighting machine when operational, but maintaining it in combat conditions proved nearly impossible." This assessment was validated through battlefield recovery data. Approximately 38% of Panthers abandoned during the Normandy campaign suffered mechanical failures rather than combat damage, according to reports from the 21st Panzer Division under Oberstleutnant Wilhelm von Schöller. The fuel system presented another critical vulnerability. Tank designer Ernst Kniepkamp prioritized performance over reliability, implementing a pressurized fuel injection system that boosted horsepower but required precision maintenance. Technical service reports from Panzer Lehr Division documented 27 Panthers experiencing engine fires during forced marches to counter the Allied breakout from Normandy, not from enemy action but from fuel system failures. Crew ergonomics further undermined battlefield effectiveness. The gunner's position, designed by Rheinmetall engineers, featured a sophisticated targeting system with 2.5x magnification Turmzielfernrohr 12 gunner's sight, technically superior to Allied counterparts. However, the cramped layout required gunners to contort into unnatural positions during extended operations. Combat efficiency studies on tank ergonomics showed accuracy declining by 35% after 4 hours of continuous operation. Panther crew commander Otto Carius noted in his memoir, "The gunner's position became unbearable after long periods in combat readiness." Manufacturing inconsistencies compounded these design flaws. When Albert Speer's ministry mandated production increases from 250 to 600 units monthly in late 1943, quality control suffered dramatically. Metallurgical analysis of Panthers recovered near Kursk revealed inconsistent armor hardening, some plates shattered upon impact rather than deflecting shells. This occurred because hardening processes required 12 hours of controlled cooling, but production pressures reduced this to 5 hours, creating stress fractures throughout the armor structure. The drive wheel interlock system designed by Professor Ernst Lehr illustrated how innovation could become liability. His interleaved wheel design reduced ground pressure to 0.88 kilograms per square centimeter, theoretically excellent for mobility. However, Eastern Front operations exposed fatal flaws when mud and ice accumulated between wheels, freezing overnight and immobilizing entire battalions. General Hermann Balk reported losing 19 Panthers in a single night near Korostin, not to Soviet action but to immobilization from frozen suspension systems. During Operation Citadel in July 1943, the 4th Panzer Regiment deployed 200 brand new Panthers, yet by July 10th, only 38 remained operational, with 131 suffering mechanical breakdowns before even engaging Soviet forces. Similarly, during the Ardennes offensive of December 1944, Kampfgruppe Piper's advance was significantly delayed when 35 of its attached Panthers developed transmission failures during the critical first 36 hours, forcing commanders to abandon their timetable. Perhaps most telling was the experience of the 9th Panzer Division near Metz in September 1944, when an entire company of 14 Panthers became stranded with failed final drives after a 35-kilometer road march. All were subsequently destroyed by Allied aircraft before they could be recovered. Ultimately, the Panther represents a case study in the difference between theoretical and practical superiority. While its 75mm KWK-42L/70 gun could penetrate 124 millimeters of armor at 1,000 meters, outclassing any Allied tank, this advantage proved meaningless when combined with a 43% operational readiness rate documented by Inspector of the Armored Forces in June 1944. As Inspector General Guderian concluded, a technically superior tank that cannot reach the battlefield represents the most expensive form of military failure,